Hello and welcome to Dell Networking Solutions Engineering. This video series acts as a primer in deploying VMware NSX on Dell PowerEdge FX2 chassis and using Dell S4048-ON as hardware VTEP. To access the comprehensive deployment guide with best practices and recommendations, please refer to the document Dell EMC NSX Reference Architecture FC430 Compute Nodes with VSAN storage on Dell Networking TechCenter webpage. In this video, we'll be looking at the topology, VMware vSphere, web client environment, and distributed port group creation. In this example, the FX2 chassis contains 4 FC430 servers, 2 FD332 storage blocks, and 2 FN410S I/O modules. The topology has 3 S4048-ON switches. One Z9100-ON is used in this example. Let's take a look at the topology that is used in this example. The FX2 chassis contains 4 FC430 servers. There are 2 FN410S modules in slots A1 and A2. These two modules are in full switch mode and are in VLT. There is a port channel running from each FN410S module to S4048-ON VLT pair. The S4048-ON on top is a primary VLT. The S4048-ON on bottom performs the role of a secondary VLT. There are connections running up to Z9100-ON from the VLT pair. Z9100-ON has a connection running up to S4048-ON, which is used as a hardware VTEP. There is a PowerEdge R630 server running Windows OS that is connected to the hardware VTEP. There is a PowerEdge R630 that is used for management. The vCenter runs on it. We will also be installing NSX Manager on this R630. The table provides details on VLANs and network used for vMotion, vSAN, and NSX. 192.168.0 network is being utilized by OSPF. Let's take a look at the command line for primary VLT. This command allows us to view the role and key status information regarding VLT, such as ICL link status, heartbeat status, and VLT peer status. The same command run on the secondary VLT displays relevant key information as well. Note that the VLT role states as secondary. We are using the routing protocol OSPF to advertise the routes. Run show IP OSPF command to look at the OSPF details. Run show IP route command to view the routes. Run these commands on secondary VLT. Run the same commands on Z9100-ON. Let's take a look at S4048-ON, which will be acting as the hardware VTEP. 10.77.4.254 is the IP address provided for loopback interface. We will be looking into hardware VTEP closely in part 5 of this video series. Let's take a look at VMware environment used in this example. The vCenter is up and running. Data Center NSX has 2 clusters, compute and management. The compute cluster has 4 hosts and 6 virtual machines running on the host. The management cluster has 1 host. vSAN is enabled. For video on how to enable vSAN, please refer to Deploying VMware vSAN on Dell FX2 chassis video. In this example, we are going to build a logical network using NSX comprising of web, app, and DB tier. Let's go ahead and create a distributed switch. In the networking section, select VM network. Right-click on VM network, choose distributed switch, new distributed switch. Provide a name for the distributed switch. Click Next. We are selecting distributed switch 6.0.0 in this example. Click Next. Number of uplinks is kept at 4 in this example. Network I/O control is left at enabled. Uncheck create a default port group. Click next. Review the settings and click finish. Next step is to create distributed port groups. Select the distributed switch compute. Right click and select distributed port group, new distributed port group. We provide the name vMotion. Click next. vMotion will be using VLAN 22 in this example. Provide the VLAN ID and click next. Review and click finish. Similarly, we create a port group for VSAN. VSAN will be using VLAN 44 in this example. Since LACP lags are used in the physical network between ESXi host and physical switches, LACP lag is configured on the distributed switch. Select Compute Distributed Switch, Manage Settings LACP. Click on the plus icon. Set mode to active and remaining fields are left to the default values. Click OK. The next step is to add hosts to the distributed switch. Right-click on Compute, choose Add and Manage Host to open the Add and Manage Host dialog box. Choose Add Hosts, click on Next. Click on the plus button and choose the hosts on the compute cluster. Click on the checkbox to configure identical settings on multiple hosts. Click Next. We select 100.67.194.13 as the template host. Click Next. Leave the selected checkboxes unchanged and click Next. Go ahead and assign the uplinks to the adapters. Click on VMNIC 0, select Assign Uplink. Select lag 1, 0, click OK. Select VMNIC 1, assign uplink, lag 1, 1, click OK. Click on Apply to All. This will apply the physical network adapter assignment as per this template host to the other 3 hosts. Click on Next. Click on New Adapter. Click on Browse and choose vMotion. Click Next. Choose vMotion traffic for VM kernel port and click Next. Provide the static IP and click Next. Review and click on Finish. Click on New Adapter and repeat the similar steps for VSAN traffic. Click on Apply to All. For other hosts, provide the static IP addresses for vMotion and VSAN. Click OK. Click Next. Click Next. Click Finish. Let's look at configuring teaming and failover on lags. Select Compute Distributed Switch. Right-click and select Distributed Port Group. Manage Distributed Port Groups. Select Teaming and Failover, click Next. Click on Select Distributed Port Groups. Select VSAN and vMotion, click OK. Click Next. Select lag 1 as the active uplink. Move uplinks 1 to 4 to unused uplink. Click Next. Review the settings and click Finish. Let's look at enabling LLDP on the vSphere distributed switch. Right-click on Compute Distributed Switch, select Settings, Edit Settings, Advanced. Choose Type as Link Layer Discovery Protocol. Choose Operation as both. Click OK. In this video, we looked at the topology, VMware vSphere, web client environment, and distributed port group creation. Thanks for watching this video. To access more networking solutions, visit the Networking TechCenter webpage.